Okay, you got $50,000 in a bank account, and they're giving you 5% interest per year. So how much money do they have at the end of the year? And you might be thinking, well, can't I just like keep $0 in my account and then put as much money as I can the last day of the year, and then I get my 5%? No, they calculate your average dollar per day. I think is what they do. Like at the end of the average dollars, out of all the days of the year. Um, yeah, I guess it's per day. I don't think they do it any smaller than that. So their average balance is $50,000, and they're getting 5% interest. So we need to find 5% of the 50,000. So if you multiply the decimal form of the percentage, and as a reminder, 5% divide by 100 to convert to a decimal. That's $2,500. That's how much money in interest that they get. So the amount of money at the end of the year is $5,250. Okay. Now it depends on several things, like whether you deposit a bunch in one day, whether they compound their interest per day. But if we just park $50,000, let it sit, and then if they calculate interest just at the end of the year, that's how much money you have. Things get more complicated. There's big formulas, but that's the basic idea. So question two, if they don't add or subtract money from this total and they leave it in the account, how much money do they have after the second year? So the idea is called compound interest year. The second year, you're having an average balance of 52,500, not 5,000, not 50,000 like before. So we need to calculate 5% of a larger number. So this year, instead of getting 2,500 in interest, we're getting 2,625. So at the end of the year, we need to add those two together. So that's $55,120. That's how much money we have in the account at the end of the second year. And so you could keep doing that. You could do it a total of 10 times to find out how much they'll have in their account after 10 years. But there's a nifty little formula we can use. This is an edit of the compound interest formula. So the way it works is A is the amount of money you have at the end of the year. Oops, let me try to move this. P is the principal, which is the starting amount. We started at $50,000. R is the interest rate as a decimal. And T is an exponent there. So it's up top in the exponent position. We want to plug in 10 years here. And so if you use a Windows calculator, you need to follow the order of operations and add the parentheses first. Then raise it to the 10th power. So I'm going to hit this exponent key and then type in 10. So that's what this parentheses raised to the 10th power is. And then I multiply that result to 50,000. Then we want to round to the nearest cent. So look, after 10 years, you haven't done anything. The amount of money in your account is $81,444.73. You could get the same result by repeating these steps over and over. For the third year, calculate 5% interest. For the fourth year, 5% interest. But that's why algebra is helpful. And that's why we need algebra for our computer programs, is because we don't want to make our computer program waste a bunch of, RAM? You nerds could tell me. And then question 4 here, a person owes $2,000 in a credit card debt, and the interest rate is 20%. You might think that's crazy. Why would they give us 5% for our savings but charge us 20%? That's how credit card companies operate. They want you to take out money on their credit card, and then they're going to charge you an arm and a leg for borrowing that money. If they made no payments on the debt for 3 years, how much would they owe after the third year? So you could use that compound interest formula, or you could compute the interest 3 times in a row like we just did, but let's use the quicker method. The principal this time is $2,000. That's the starting amount. Oh, it's 20% as a decimal is 0.20. And then the exponent this time, shift 6 gets you the caret key. Sorry. And that means an exponent. Okay. So same process. Want to add 1 plus 0.2. So that's 1.2. Raise that to the third power. Hit enter, then multiply this to 2,000. So it's $3,456. So if you just let your money sit there, and if we assume simple interest, well, that's not really simple interest. If we assume things are just compounded at the end of the year, which is a simpler way of doing it than how it actually probably happens, then you're going to owe $3,456 at the end of the third year. So just by not paying off your debt, you get yourself $1,456 more in interest to pay.